Grade 12 Physical Sciences learners. Audio 1 on the topic of electrodynamics. Paper 1. This topic needs understanding and practical imagination. Get hold of the examination guidelines 2017. Any other grade 12 CAPS Physical Sciences textbook. Electrodynamics is the branch of physics that deals with electricity, magnetism, and mechanical phenomena or movement. In the examination guidelines, you are expected to study the electrical machines, generators, and motors. Let me start with the motors. I would prefer to start with the electric motor because it's user-friendly to drivers. Examples of appliances using electric motor are the car, washing machine, sewing machine, etc. The principle in which the electric motor works is known as the motor effect. Practical example: when the car does not start, the mechanic checks the battery, the starter, if the brushes are not finished. Open the bonnet of the car. Have a look at the 12-volt battery and the cords. Someone must start the car to see where the starter is located. When you are starting the car, the current flows from the positive terminal of the battery to the left side brush to left part of the split ring commutator to the rectangular coil to the right side of the split ring commutator to the right brush attached to the negative terminal of the battery. You can feel from the key that the car has started. As a driver, you are able to hear the change of sound from electrical energy into mechanical energy. How an electric motor works. Have a look at the schematic diagram of the direct current electric motor figure 1. Start understanding the structure from the battery. The 12-volt battery is connected to the brushes. The brushes on both sides are attached to the split ring commutator. The split ring commutator is holding the rectangular coil by a pivot. The size of the rectangular coil can be indicated by symbols A, B, C, D in most grade 12 physical sciences textbooks. The rectangular coil inside the magnet is indicated by north and south. Then the functions of the components of a car. A battery produces direct current. As a result, a motor car's windscreen wipers are driven by the direct current. Brushes are made up of carbon. They do not rotate. They provide electrical contact between the battery and the split ring commutator. Brushes allow split ring commutator to rotate freely and also allow the flow of current in and out of the coil. The split ring commutator is a metal ring that has been split into two halves. There is a gap between the two halves. Split ring commutator allows for constant direction of the coil. A commutator reverses the direction of the current in the coil each half cycle when you are driving the car. The rectangular coil is made up of a number of turns or windings. The speed of the motor car is determined by the number of turns or windings. The rectangular coil pivots about an axis. It is placed between the two magnets of opposite polarity at the north and south. Direct current motor uses a permanent magnet. Then how the coil rotates. The coil is in the presence of uniform magnetic field directed from left to right. Using a Fleming right-hand rule taught in grade 11 to determine the direction of force on the conductor, the direction in which the coil rotates, or the direction in which the coil turns. Remember, the thumb points the direction of the force. The first finger points the direction of the magnetic field. The middle finger or palm of fingers point at the direction of the conventional current. Use the right-hand rule. Label the vertical side as AB. The magnetic field is always perpendicular to the force. The force is downwards now. Current moves inwards at the coil. In the horizontal side BC, no force, since the current is parallel to the direction of the magnetic field, is that moment when the machine is silent. On CD, the magnetic field is upwards. The current moves out of the page. On AD, no force, since the current is parallel to the direction of the magnetic field. The current flows through the coil from A to B to C to D. Forces in AB and CD create a turning effect on the coil, causes the motor to rotate in an anti-clockwise direction. The motor rotates in an anti-clockwise direction. On BC and AD, no force, since current is parallel to the direction of the magnetic field. This is more noticeable in the washing machine, the time of silence, as if it's not working. The force experienced by a coil can be increased by increasing the strength of the magnetic field, by increasing the strength of the current in the coil, by increasing the number of turns or windings in the coil. That is all with regard to the electric motor. For better understanding, practice this diagram of the electric motor. Read it from the battery, because it's changing. Electrical energy is converted into mechanical energy. That's all for today.